Okay, our next lesson will be inverse of quadratic relations. Inverse of quadratic relations. So they are the same as linear relations. So only thing this is quadratic, the other one linear, but it's the same concept. So let's see if I have a fx is equal to x squared plus 1. If I see this one here, the domain of quadratic is always all real numbers. We know that from previous lessons. X belongs to R, and the range of this will be depending whether it is maximum or minimum. In this case we have the minimum, and the minimum value is 1. So y belongs to R such that y is greater than or equal to 1. That is the range. So now as we see, to find the inverse, we say we exchange x and y. Fx is y, so instead of y I write x, instead of x I write y squared plus 1. I always isolate y, so x minus 1 equal to y squared. Therefore y equal to, whenever I write the square root by myself, I write plus minus square root of x minus 1. Okay, so let's see this one here now. The domain, we know the domain of this. The domain is, as we know, inside the square root cannot be a negative number. So x belongs to R such that x must be greater than or equal to 1. And the range, since this is plus minus, it's all real numbers. So as we see from our definition, see the domain is x belongs to R, range is y belongs to R, that means they exchange it. Range is y greater than or equal to 1, and x is greater than or equal to 1 for the domain. Therefore they always exchange. So what we say is this a function? Is the inverse a function? So let's see a graph of these ones here. Okay. So if I see the graph here, x and y, the original graph is x squared plus 1, which means x squared plus 1 is here. This is fx x squared plus 1. This is 1. So the inverse is from starting at 1 here, x minus 1 starts at 1. It's like square root graph, which goes to, this is a positive 1 and this is a negative 1. So this is f minus 1, which is plus minus square root of x minus 1. So if we see this is a mirror image, we say it's always a mirror image on y equal to x. This is an image of that. So is the inverse a function? We know this parabola is a function because of vertical line test, but this is not a function. So the inverse is not a function. But in order to make it a function, we restrict the graph, we restrict the equation. So to make it a function, restrict the domain. Restrict the domain. That means, restrict the domain means I can take one branch here or the other branch here. So this is the value of x is 0. Therefore I can say either I take only x greater than or equal to 0, or I can take x less than or equal to 0. to make it a function, I take only one of the branches. If I have only one branch, it will be a function. So that's what we do to restrict the domain. Okay, so let's see if I had okay, let's see B. If I have y equals square root of x minus 5 plus 2. Okay, first of all, to find the inverse, I interchange x and y. Instead of y, I write x square root of y minus 5 plus 2. To isolate the 1 inside the square root, I have to bring this to the other side. X minus 2 equal to square root of y minus 5. In order to isolate the y, I have to square both sides. X minus 2 square root of y minus 5 square. Then I have x minus 2 square. If I square a square root, I get only y minus 5. Now we said we have to isolate the y. To isolate the y, I have to bring the 5 to the other side. Plus 5 equal to y. And this is the inverse, f minus 1. So the inverse of this is that. We will see the graph, and the graph we see if it is the inverse is a function or not. Okay, so let's see another question. C. If I'm given in standard form y equal to x squared plus 6x plus 1. This looks a little bit difficult, but it's okay. Let's see. Interchange always x and y first. X equal to y squared plus 6y plus 1. As we see, I cannot isolate the y here because there are two y's here. This is y squared, this is y. So to isolate this one, I have to make it in this format here. That means I have to change this one to vertex form. To change it to vertex form, I have to complete the square. Complete the square means I have y squared plus 6y. In order to complete the square, we said I take half of 6. Half of 6 is 3. 3 squared is 9. Plus 9 minus 9. So complete the square. This y squared plus 6y will be this one here, because I add and subtract a number, so that I'm adding only 0 to the number, plus 1. X equal to y squared plus 6y plus 9. This is a perfect square, so I say this will be y plus 3 square. If I factor that, it will be y plus 3 square. So what's remaining? Minus 9 plus 1, which is minus 8. Okay, so now to isolate the y, I have to bring the 8 to the other side. X plus 8 equal to y plus 3 square. And then y plus 3 only will be square root. Plus minus, I write plus minus always. X plus 8 equal to y plus 3. From this one here, I say y equals plus minus square root of x plus 8 minus 3. And this is the inverse of this. Okay, that's all about inverse relations.